Hello students, welcome to this new lecture on Snell's law. It's a continuation of Snell's law, and there is an application called total internal reflection that we are going to study, TIR in short form. And the conditions for TIR is the incident ray must travel in a direction from denser to rarer, and the angle of incidence must be greater than critical angle. So these are the two statements. They are very simple statements. So let me explain them, and then you will understand what these two statements mean. So suppose I have a boundary separating two medium. Let us say I have this boundary, and there is an object here, right? Now the rays from this object are going like this. Some of them are going straight, so they will not bend, they will continue like this. Some rays will be going like this, right? Now suppose this is the denser medium, this is the rarer medium, and rarer medium means the refractive index is mu r, and the denser medium, the refractive index of denser medium is mu d. So the incident ray is going from denser to rarer, so first condition is satisfied. Also, if you draw a normal, it will bend away from the normal, yes or no? Now if you increase the angle of incidence, let's say it is striking here, as you can see that this angle is greater than this angle, so the angle of refraction will also increase, so R has also increased, right? Now there comes a stage when it strikes at a much larger angle of incidence, such that this ray almost becomes parallel to the principal axis. So parallel to the surface, right? So you can see here that this ray is now becoming parallel to the surface, right? So if it becomes parallel to the surface, we call this ray as grazing ray, and the angle with normal becomes 90 degrees, as you can see here, right? So this angle of incidence is known as critical angle. So if we are asked to define what is critical angle, then critical angle is simply the angle of incidence at which the angle of refraction becomes 90 degrees. That's the definition, right? So let us now use Snell's law, right? Snell's law says that sine I by sine R, so sine IC by sine 90 will be equal to mu R, because mu R is the medium in which it is going, and it is coming from denser medium, so mu R by mu D, right? We can also simply write like this, mu D by mu R, yes or no? Mu D by mu R. So what is mu D by mu R? It is the refractive index of, what is this? Refractive index of denser medium with respect to rarer medium, and sine 90 gives you 1, so sine IC will simply be, this is 1, so this will be like this. So IC, critical angle, can be found out by using this sine inverse of 1 by R mu D, right? So this is how you find critical angle, right? Now the next question before us is that if the angle becomes even greater than critical angle, then what is going to happen? Suppose this ray is going at a much larger angle, so it is striking the interface at an angle which is greater than critical angle. I is greater than IC. So for this ray, what happens is the TIR condition is satisfied, angle of incidence is greater than critical angle. So what happens is this ray does not go into the next medium, it reflects back into the same medium following the rules of reflection. So let's say if this angle is 80 degrees, so this angle will also be 80 degrees, because angle of incidence is equal to angle of reflection. So this phenomena is similar to reflection, except that we are not using mirror. It is just two transparent medium, and light is going from one medium to another, but it is not entering into the other medium. It is reflecting back into the same medium, which is the denser medium. That is why we call the term internal. Internal means in the same side of the incident ray it is reflecting back. It is not going into the other medium. And the interface is, behaving like a mirror. It's not a mirror, it's behaving like a mirror. And it behaves like a perfect mirror, which means there is no loss of energy. Whatever incident energy is there, that incident energy is completely reflected. So it is behaving like a very good mirror, 100% reflection. So this is 100% reflection, and this is phenomena is known as TIR. So what are the two conditions for TIR? Number one, it should go from denser to rarer. So it is going from denser to rarer, as you can see. Ray is going from denser to rarer. And the angle of incidence must be greater than critical angle. We can see that I is greater than IC here. So it reflects back into the same medium. Now this phenomena has several good applications in physics, like mirage, diamond, and optical fiber, which we will see in the next lecture. Thank you.